We'll move on to the next talk. And this is by Natalie Laudier, NOAA NESDIS Commercial Data Program.
All right, good morning, everybody. My name is Natalie Laudier. I'm a branch chief at NESDIS NOAA. I introduced myself yesterday if you weren't here. So, but this is really a talk. It's a team effort really for our commercial data program, as well as our analysis of alternatives that we're working on for radio occultation. So I'm going to go through those, reiterate some of the results that Billy provided yesterday as well. But several of our team members are here too. So if you have any questions after. NESDIS is very interested in maintaining a RO hybrid system. Partnerships are absolutely critical to this, to meeting our NOAA mission requirements. We partner with commercial, with international partners, as well as interagency. Melissa talked about our potential partnership with NASA coming up for our next delivery order. So that's in the works now. We purchase radio occultation data through our commercial data program, and we're also working on understanding where are the gaps in radio occultation as cosmic 2 degrades through our AOA study, and I'll cover that a little bit later. And looking to understand what are some potential solutions to fulfill those gaps. So I'm excited to announce that we have a new commercial data by guidance for NOAA. So it's available for public comment right now, but really our office is not the only NOAA office that buys commercial data. So it's good to have that strategy across our organization and framework. It's not a policy document, but it is a guidance on how we want to continue with our commercial data buys moving forward for NOAA. And actually, Jerry Peltzer helped work on that document. He was here. If you have any questions about it. So our commercial data program really allows us to take a look at new commercial data sources that can support our space-based environmental monitoring mission. Our commercial data purchases are used for operations. They feed into our NWP models. And then our commercial weather data pilot, this allows us to get an early look at new commercial data sources coming out, and we evaluate them, assess the data quality, look at how impact operations, how they can help support our operations within NOAA. And that's our CDP website there if you're interested in taking a look at some of our projects. So our operational purchases really are critical for us. They support the operational weather models and add value. I'm excited to announce our delivery order 4 was just awarded. We awarded to Planet IQ and to Spire for a total of 3,000 radio occultations per day. And then so that'll start on 18 September. And we are aware that this is somewhat last minute. We did expect to award earlier, so we're in this transition phase right now, and working to integrate these data sources so we can have a continuity of operations. And the chart to the right here shows the amount of our data that's assimilated. So the commercial adds a lot, as well as Cosmic 2, of course. But that's a combination of both UMET, SAT, and our U.S. commercial data program purchases. And this is a breakout of that. So this will change as of the next delivery order, and will include more Planet IQ data as well. So I don't have to tell this community that our RO benefits, commercial RO really does add value. It really improves our forecasts accuracy. The thing we're very interested in is some of the results coming out of Romex. We're interested to hear that this week, to see the impacts of more radio occultation data and the impacts to our NWP. So for our commercial weather data pilot projects, these really allow us to take an early look at some of the data. These are two examples of two recent pilot projects. Our space weather pilot project, which Mark Gasparo will brief later next week in more detail. But I'm excited that we have a final report out, and that's now released to the public. So you can take a look at that if you're interested. And then our ongoing ocean surface winds pilot for GNSS reflectometry. Jerry Peltzer will brief this right after this, actually. So you'll learn more about status on that. So NESDIS really does prefer the unlimited distribution licensing. We prefer less restricted data sharing. For our pilots, they are a bit more restricted while we're testing out the data. So we do allow it to be a little bit more restricted during that time. These are some additional weather pilots as well as projects. So we will soon be awarding a new microwave sounder pilot, and to start towards the end of this year, we're going to investigate the utility, the quality, impact on operations, and we're able to leverage some of the past work from the NASA Tropics mission as well. And then we have some ongoing projects where we are looking into hyperspectral microwave soundings as well. And we're leveraging the work from our joint venture program on that. We are looking into polarimetric RO and starting to investigate utility of that. And then space weather, continuing coordination on space weather, although we don't have a full-blown pilot on that at this time. This is our notional schedule. So on the top are our pilots. We have our ocean surface winds pilot, and we would really like to have a follow-on pilot to this after our evaluation period, but it's pending our results from our first evaluation and study. And then we have a 12-month period for our microwave sounder pilot. And then we plan to release another general RFI at some point next year. So that way we can understand where industry is and where they're going better. For the purchases on the bottom portion, we have our delivery order 4 just ending, and then DO5, DO4 just starting, which will be a year, and then DO5 for next year. And we'll probably put out a IDIQ on-ramp release, which means other new RO vendors can join our IDIQ if they meet the requirements as well. This is a plug for our commercial CDP Community Day on September 26th. It'll be virtual only, but we're going to focus on our general request for information process and what we do with that information that comes in from industry, and then how we choose our pilot projects and projects moving forward after getting that information. Feel free to register. All right, so moving on to our AOA, Analysis of Alternatives, our phase 1 overview. So I just want to start by saying that this was a very rushed AOA. it took about, I think we probably had about 4 months-ish, if that even, maybe 3, once we got everything all situated and together. But it was very very rushed, but I'm excited to say, and you should feel lucky because this is the first time we've actually briefed anyone other than Dr. Volz and NESDIS leadership on this, on the results. So yeah, we're very interested in getting your feedback on it and what we can do to improve the process. Billy Galata is organizing a lunch to further discuss and get feedback from everybody today. So please attend that if you're interested. Let's see. So yeah, and this was really a team effort. So we worked a lot with different NESDIS offices. SWO folks are here, I think somewhere. Leo, as well as Aerospace and UCAR. We had a great group of people putting these together. So it's definitely a team effort. So what we did was we really needed to identify the gaps. So what are the gaps associated with the degradation of cosmic 2? And then we looked at different alternatives on how to fill those gaps. So that was the main driver of phase 1. We looked at performance over time and associated costs and risks. I'm not briefing the cost portion. And then looked at different parameters and how those meet or don't meet our NOAA requirements. So we used several different NOAA requirements documents to have our requirements baseline for this. Okay, so in conclusion with the counts requirements were very easy to meet. So we did use 6,000 count requirements for this. We did take a look at bumping up those numbers as well, but in general, counts were fairly easy to meet. And this is a count without commercial. So if we don't have any additional commercial as cosmic 2 degrades, it looks like we go lower from our requirement, below our requirement in around 2035 time period. So that's only if we continue having our baseline and no additional commercial. And this is our refresh. So our refresh requirements were every six hourly refresh and a 90% time or 90% coverage of refresh. So really our requirement is uniform distribution for radio occultation. And this is what we're using to characterize that. We had some discussions yesterday about how we might need to use a different characterization of this. So we need to continue some of those conversations. So you can see that we're really not meeting our refresh for 6 hours. We somewhat meet it in the tropics because of cosmic, but we do not meet it for global, mid-latitude, and polar currently. And this is with an additional 4,000 commercial as well. So you can see the kind of the degradation, and as in our refresh goes from about 90 down to 75% around 2031-ish. So this is where we took a look at filling the gaps. And this is only one of many, a few of many plots. Chris Barsoom's here. Actually, he developed a lot of these plots. So these are just a few that we're showing, but these are an example of how we could potentially fill these gaps and what would be required. So it's really, we need that coordinated and diverse orbit capability. So we can't just have everything in the same plane, the same orbit. It needs to be spread out in order to have more uniform distribution. So this is this shows a notional launch in 2029 of 6 satellites at 30 degrees and then 2 at 98 degrees. So whether it's commercial providing this, a NOAA capability, partnership capability, we don't know, and we're analyzing that in the phase 2 right now. Let's see. So, yeah, so for results, our counts per day is much easier to meet than refresh. We really need this uniform distribution, and it cannot be met currently just by partners and commercial data. We're looking at alternatives for NOAA own constellation in low inclination orbit, in addition to having a coordinated and diverse constellation, high inclination orbit in order to meet our requirements. So right now the question that we're trying to answer for phase 2 is what is the impact on NWP if we don't meet our 90% requirement? Why do we need to meet that 90% requirement? So that's what we're trying to answer in the next phase of our study. So for phase 2, we're working on OSSIs, model sensitivities. We will potentially adjust as needed as ROMEX results come out. We could potentially adjust our requirements in this study. We want to expand our partnerships in this study and analysis and understand other requirements out there, not just NOAA. We had to simplify this first study because it was so fast. We only did neutral atmosphere. So for this one, we want to add in space weather. So we're going to add in TEC and scintillation. And then we need to go back and optimize some of our modeled constellations and take a look and reassess some of the alternatives. This is our organizational email, as well as some team members. So please reach out if you have any questions. And again, we're holding that AOA RO lunch, working lunch. So please join if you can. And this is our website.
I think we have time for a few questions, Ben.
Natalie, it would be very interesting, even for me, to see this about so-called NOAA-owned satellite at the LEO and including. Can you say more about it?
I'm not sure I understand the question.
So some of those options you actually mentioned that NOAA owns, so NOAA built their own our mission and combined with others. So can you say a little bit more about it?
Yes. So we're not necessarily analyzing if it's NOAA owned, commercial owned. We have different models we can look at, GOCO, COCO. So yeah, I mean, let's see. We are analyzing that, but we're looking at what it provides right now. We're not looking at exactly who owns it.
Maybe this question is a follow-on. You mentioned some of your projections, a launch in 2029, which I assume means a NOAA-owned satellite or constellation. My recollection is that it took 8 years to develop and launch Cosmic 2, and we're already within 8 years of 2029. Is there sort of a kind of an estimate of how long it would take to actually develop a constellation? I mean, it seems like you're in a somewhat fast timeline if you want to get something up by 2029.
Correct. Yeah. So that's only a notional launch to look at our gaps and filling those gaps. That's not the timeline, but we have spoken with Leo about it, and it's about 5 years-ish. So it would be longer.
I had a couple questions. One, we've been certainly following like Dr. Morgan on the quantity through the Aussies and the international communities on looking at the 6,000 to the 10,000 to 20,000 occultations per day versus the impact on the weather forecasting and the improvements from that. So from looking at that versus the budgets that Congress is putting into commerce to actually do the radio occultation buys, we're going much faster. And certainly a lot of the analysis that we see here is, hey, the commercial marketplace is static. And that's not really true. We're launching more, Spire's launching more, other people are getting into it at different LTDNs at different times of day to make sure that the radio occultation is across all diurnal cycles. So, I mean, that's what we're looking at from that. I totally agree with Eric on public domain data licensing, and I think that's all super great. But one of the things about the studies that NOAA is doing right now is looking at, hey, this is static at 4,000 occultations per day from the commercial markets, and that all the other Aussies are looking at the 20,000 and above, both the ECMWF and Nikki Priva at GMAO. So it's one of those things that we all need to go faster. NOAA does, the commercial market does. It looks like we're still being kind of slow. I don't know what to do about that, but I just encourage NOAA to go faster and work for the quality and the quantity and insist on diurnal cycles, because anybody could do that. It's just, can we actually do that in a time frame that you have? And Eric's right. It's like, hey, if you're going to do a government program, how many years do you want to do that planning to catch up to this? That was more just a comment, not a question. So
Okay, I do want to correct something though. We are looking at different numbers of commercial data. I think we went up to 12,000 this time around, but that's the current commercial orbits. We're not looking at what they could be in the future. That's what the NOAA portion of this is, the NOAA launch portion, which could be fulfilled by a commercial entity.
So it's not just a question to you, but also to the commercial data providers. So I got that you need a replacement of Cosmic 2, right? So you need the satellites in the 33-degree inclination orbit. And I don't doubt about the numbers of commercial data you can get, but is it very likely to get the data in the 33-degree inclination orbit from commercial data so far?
In which orbit?
Is it likely that you get the commercial data from satellites in 30-degree orbits, which are not so usual?
That's what we want to have the conversation with the community about, with the commercial industry too, is that different launches even possible, different orbits even possible in the future. Because if these are our gaps and this is what is causing a gap in NWP, then maybe we need to think about that in the future.
Okay.
Thanks.
So our next speaker is Gerard Pelzer, and he will speak on the NOAA NESDIS GNSSR ocean surface winds